Okay, with this next project, we are going to create a macro program that will allow you to learn the following skills. One, you'll learn how to automatically set up a macro so that it automatically runs when the spreadsheet is opened. We'll learn how to use a command button to execute a procedure. You'll learn how to use a random number generator. You'll learn how to round off numbers, and you'll learn how to define global variables. Basically, what we're doing here is we're going to create a reviewer, so to speak, something that you can use to review for your tests. Uh, we're going to create a macro that would solve a problem. The problem of determining the pressure in atmosphere due to a liquid column given its height in centimeters and its density in grams per mil. If you remember, pressure due to a liquid column is equal to its density rho times acceleration due to gravity times the height. Okay? So if you have the height in meters and you have your density in kilograms per cubic meter, and acceleration due to gravity is given in meters per second squared, everything in SI, then your answer is going to be in Newton per square meter or a Pascal, which is what a Pascal is. Okay? So, but in this program, we're going to have our pressure entered in atmosphere, our height in centimeters, our density in grams per mil. So you're going to have to convert those first to SI units. Okay? So we're going to create a program. We're going to define our height, our variables as height, density, and correct answer. We're going to define them as global variables because we're going to be using those variables in two procedures. Okay, more than one procedure actually. It's two, I think three. So if you have variables that you use in different procedures and you want the variables to carry over, then you need to define them as global variables. Any variable you define within a procedure is not declared as a global variable will retain its value only while you're inside that procedure. Okay, we're going to set our initial height to 76 centimeters and in density 1.36 grams per mil. So that would be about a tenth of the density of mercury. So you would expect, since 76 centimeters of mercury is 1 atmosphere, you would expect that 76 centimeters of this liquid is going to have a pressure of about 0.1 atmosphere. That's just a way for us to verify our numbers quickly. Okay. Now, we're going to add a button called Submit Answer first, and then so that when the user clicks on that button, it executes a macro that would compare the answer to the correct answer, tell the user if it's correct. And then after that, we're going to add a button that says Generate Another Question, and a handler. That's a program that will run when that button is clicked, that will randomly change the value of the height to a number between 30 and 90 centimeters and randomly change the density to a value between 0.8 and 1.5. And then also calculate the correct answer so that if the user clicks on submit the answer again, it will verify. You can check if the user actually knows how to calculate the pressure. Okay, so let's go ahead and do that. Alright, so if you open an Excel spreadsheet, let's go ahead and do that now. We're going to start off by setting up our question. So we're going to resize column A so we can type a long text here. So that's something like this. Calculate the pressure due to a column of liquid of height. And we're going to say we're going to put the height of the liquid in cell B1, okay, centimeters, okay. And if the density of the liquid is, and we're going to put that density in cell B2 and our unit here in cell C2. And to make it look a little easier to read, we're going to align that with the right side of your column. So calculate the pressure due to a column of liquid of a given height if the density of liquid is given as these numbers right here. And then we're going to tell the user to enter the answer here. Answer in cell B3. Okay, and the answer was B in atmosphere. Now we're gonna create a macro now that would initialize the value of this to 76 centimeter and initialize the density to 1.36 grams per milliliter. So you go, as usual, you go to view, macro, record macro. Now, if we want this macro to run automatically when the spreadsheet is open, we have to give it a special name, and the special name you can give it, instead of calling it macro 1, you call it auto underscore open. And we want to be able to run this without having to close and reopen the spreadsheet, so I'm going to have a shortcut key to access this macro. I'm just going to say I want this to be accessible if I press Control I. I'm using I because I want that to remind myself that by pressing this, I'm going to initialize the macro, initialize the variables in the program. Okay? I want to define the initial values of things that I'm going to be using in my program. So I'm going to click OK, and now I'm going to go stop the macro and then view the macro, and there's auto open right there. I edit it, and this is what I have. I do nothing macro right now. So what I'm going to do is I'm going to define density and height, right? So density is 1.36, height is 76.0, and let's see, what else do I need to define? Correct answer. First of all, before we do that, let me just put these values in my spreadsheet. Okay, so my spreadsheet says B1, so that's cell, row 1, column 2. Okay, so cells 1, 2 should have my height. So I switch back to my macro. So cells 1, 2 is my height, and cells row 2, column 2 would be my density. Let's just see if that works. Okay, I press Control I, and it does give me that. So we're okay there. And let's go back. Now I want to calculate the correct answer. Correct answer is equal to density, but I want my density in kilograms per cubic meter. So anytime you have grams per milliliter as your density, all you have to do is if you work it out, you'll find that all you have to do is multiply that by 1,000. That gives you your density in kilograms per cubic meter. You multiply that by acceleration due to gravity, which is 9.81. And you multiply that by the height in meters. Since my height is in centimeters here, I divide it by 100. That would give me the answer in Pascal. Okay. Now, if I want the answer in atmosphere, then I have to divide that by 1.01325 times 10 to the 5th. Okay, there's 1.01325 times 10 to the 5th Pascal in an atmosphere. And then let's verify what that answer is. Let's do a message box to just echo that. The correct answer is, yes, close quote, and then you have an correct answer. Okay, so let's verify. Control I, and it says correct answer is 0.1000, and so on and so forth. Now, I want to round that up to just 3 decimal places, so this is what I'll do. I'm going to use the round function. Okay. I'm just going to say correct answer equals round correct answer to 3 decimal places. And let's verify that. See, correct answer is 0.1. You notice it doesn't put the trailing zeros. It's 0.100. Okay, so that's my expected answer. So that should be okay. Okay, so I'm going to give you a little time to get caught up. Here's the macro that we have so far. Oh, yeah, one thing. Let's save this first. So I'm going to save this as project 3. then it should be save as an Excel macro enabled workbook. Okay, I already have one from earlier. I'm just going to go ahead and overwrite it. Okay, so now let's see if I were to close this and then reopen Excel project, reopen it. Okay, it should automatically give me my, it automatically runs the macro, you can see. Okay, so let me get rid of this and let's save it. Let's do it again, run it, and you can see it automatically, even though when I saved it there wasn't anything here, it reinitialized it. Okay, so the initialization program works. Okay, so now you can go get caught up, and then we'll continue in a little while. Okay, the next thing we need to do is give the user a way to submit the answer after entering it in cell B3. So let's go back to our spreadsheet right here. We want the user to answer cell B3 here, and then click a button somewhere down here that says submit, and then that will trigger a procedure to run that will check whether the answer submitted was correct or not. Okay, so what we're going to do is go back to our macro, and we're going to create a procedure that will check the answer. So you say sub, I'm just going to call that check answer, and you'll notice this end sub automatically shows up every time you do a sub. That just tells you the end of the procedure. So you enter your code between the two. So this procedure checks the answer. Okay, so we will get the answer from cells B3. So that means column 2, row 3, column 2. Okay, so that's cell B3. And let's just verify that that is in fact the case. Message box. Your answer is an answer. Okay, let's see. Let's go ahead and do that. Oh, we have no way of doing it right now. We're going to need to have a button that would do that for us, that would execute that program, since we did not create that macro with a shortcut control combination. So what you need to do is go to developer. Okay, if you don't have that on your Excel sheet, on your menu, then what you need to go is go to file, options, and turn it on. It's under customize ribbon, and right here on the right hand side under the main tab, okay, one of those main tabs says developer. It's probably unchecked if you don't see it, so make sure that one is checked. Okay, so you go to developer and then you insert, and then see form controls here. The first one over here is a button. We're going to insert a button, and then you're going to put a button somewhere here that says submit. Okay, and now this is the first button, so it's automatically given a handler called button1 underscore click. That procedure will run if you click on that button. That button is called button1. Now we already wrote the handler for this button. When you click it, and we call that handler check answer. So we're not gonna accept that button1 click. We're just gonna click on check answer. We're gonna associate that with the button. Okay, so when the button is clicked, that check answer procedure will run instead. So I'm gonna click OK, and now I can just change the name of that button. I can just say submit. Okay, and click out of it. Let's see if it runs the macro. Submit. And you can say it says your answer is blank. Right now we don't have any answer. Let's click something. Let's put something here like 0.3. Hit submit. You can say it says your answer is 0.3. Let's try 0.2. Submit. It says your answer is 0.2. So that button is doing its job. Okay. So next thing we need to do is so let's go back to that macro. Check if whether that answer is correct or not. So you say if answer is equal to correct answer, then you say, let's do a message here, message box, good job. else, you send a message that says wrong and if. Okay, so let's do that, and let's see, submit. It says your answer is 0.2, its answer is wrong. Okay, what's the correct answer? It's 0.1, right? So let's see if it will say 0.1 is correct. It doesn't say that. Let's verify. Let's verify if it knows what the correct answer is. You can say message box, the correct answer is correct answer. Okay, and so let's run that program again. Submit. It says your answer is 0.1. The correct answer is blank, so your answer is wrong. Okay, why did it not have the correct answer? We calculated that correct answer already. Well, you have to go back now and see that this variable right here is okay, and this correct answer over here are not the same thing, because this correct answer here is only accessible within this procedure. So this procedure, check answer, cannot access the value of this variable in this other procedure. If you want correct answer to be the same and accessible by all procedures in your program, then you have to declare that as a public variable. So you say public. In fact, we're eventually going to need density and height as public variables as well. So public, height, and correct answer, we're going to make those public variables. So now let's run this. You're going to say submit. You can say your answer is 0.1. Now that's not the correct answer. And hit OK, wrong. So let's just go ahead and reinitialize this. Control I, correct answer is 0.1. Submit, your answer is 0.1. The correct answer is 0.1. And it says good job. Okay, so that's how you make sure that a variable is accessible everywhere in your program. Okay, you want to minimize the use of those because sometimes it could lead to confusion. All right, but it's necessary in some cases. In a lot of cases, you kind of have to know how to do it that way. So submit. Your answer is 0.1. Correct answer is 0.1. Good job. If I try 0.3, I hit submit. Your answer is 0.3. The correct answer is 0.1. And it says wrong. Okay. So let's go back. And time for you to get caught up. Okay, let's continue. This time we're going to write a macro that would now randomly replace the height by a random number between 30 and 90 centimeter and the density by a random number between 0.8 and 1.5 grams per milliliter. Okay, and then we want that to calculate the answer, so that when the user puts in the answer here and clicks submit, it will check check the user's answer again and see if the answer is correct. Okay, so we're gonna change these now. So let's go create another macro. We're gonna call that macro sub generate Q. Okay, generate Q will respond to a button that says generate question. Okay, so we're going to insert, go to the developer tab, insert another button that says, and okay, that's their second button. You'll notice it says button 2 underscore click, but we already have a procedure that will handle that. We're not going to call it button 2 click, we're going to call it generate Q. So we can associate the procedure generate Q with that button, and we're going to hit OK, and we're going to rename this button. We're going to call it generate new question. Okay, so what it does is it changes values of B1 and B2 and recalculates the answer. So if you click on that right now, it's not going to do anything because we haven't done it. We have a do nothing macro so far. So what can we do here? If we want to generate a new value for the density, then we're going to say density, we say is going to be between 0.7, 0.8 and 1.5, right? So 0.8 plus RND times 0.7. So what does this mean? RND is a number between 0 and 1. That's a random number that Excel picks between 0 and 1. So if the lowest possible value for RND is 0, so if it's 0, then density is 0.8. The highest possible number for RND is 1, so if RND is 1, you got 0.8 plus 0.7, that's going to give you 0.15, 1.5, sorry. Now your height is going to be a random number between 30 and 90, so I'm going to say 30 plus random times 60. Okay, again, the lowest possible value for random is 0, so the lowest possible value for height is going to be 30, and the highest possible value is going to be 60. And now I'm going to assign those to cells 1, 2. It's going to be our height, right? And cells 2, 2 our density. Okay, actually, tell you what. We've done something like that earlier in the initialization. This thing right here, the height is assigned to cell B1, the density is assigned to cell B2, and then we have our correct answer calculated. Okay, and we have the correct answer if you want to tell the user what the correct answer is. Okay, so we have that. Let's go ahead and go back to our spreadsheet and let's generate a new question. It says the correct answer is 0.0. You'll notice it's already changed the height to 62.00544 centimeters and the density is 1.29. So the correct answer is now 0.078. So if I answer 0.3 now, it's going to say 0.3, answer is 0.078. The answer is incorrect. Okay, so generate a new question. You should see these numbers change. You can see it's now 47 and 1.2. The correct answer is now 0.055, right? So if I answer 0.055, submit, it says the answer is correct. Good job. Okay, generate new question. Okay, and now the answer is 0.075. Now, when you're generating a new question, you probably should erase the user's answer here. So let's do that. So let's do cell 32. Okay, that's where the user put the answer in, right? Cells 32. Equals, and then 2 quotation marks. That puts that pretty much deletes what's in that cell. Okay, so let's try that again. So now when you generate a new question, it leaves it blank. Of course, you don't want to tell the answer, but that was just our way of checking whether the answer was correct or not, right? So knowing what the answer is. So let's go back now to refine this. We don't want to tell the user what the correct answer is. Okay, let's continue refining this program that we have here. So you'll notice if you click on generate new question, every time you do it, these numbers here have too many decimal places. So let's fix that. Let's go back to our code. What we can do is we can round off our density to 3 decimal places. So you say density equals round, density, comma 3. And we're going to round off our height to 1 decimal place. So round, height, comma 1. Okay. So if you do that, next time you generate a new question, you can see you got 1 decimal place for the height and 3 decimal places for the density of the liquid. Okay, 3 decimal places there. Now, sometimes you'll notice, look right here, instead of showing 1 decimal place, it shows no decimal place. And the reason for that has to do with trailing zeros, which Excel by default sets to doesn't display. So what you need to do is right here is you can format the cell and set the number format to explicitly show the number of decimal places you want. Okay, so now it's explicitly showing 62.0, and this one you want it to explicitly show 3 decimal places. So format the cell, click on number, and then 3 decimal places right there. Okay, now let's get rid of these numbers and save this so that we can verify next time you load it up, it will format the numbers correctly. So let's go ahead and exit out of here. Exit. Okay, now let's try running the spreadsheet again, and you'll notice by default it goes back to 76 and 1.36. The correct answer is 0.1, and you see that those two buttons right there. If I generate a new question, you'll notice it now does have just 1 decimal place for the height and 3 decimal places for the density. If I submit my answer, it says your answer is blank. Correct answer is 0.059. Okay, you're wrong. So 0.059. Let's try that. Submit. Your answer is 0.059. Correct answer is 0.059. Good job. Okay. Now, what if I entered 0.0589? Okay, let's just say I made a very slight mistake in my calculation. I'm slightly off in my calculation. If you hit submit, you'll notice it will say the answer is wrong. So you probably should give your code some kind of check, a way to check if the answer is close enough to be acceptable. Generally, when you have numeric answers, you don't want, most of the time, you don't want exact answers. You want to give the user some leeway. So what you can do is you can put you can change your code right here. So let's go back to our macro for the check answer. Okay. Instead of insisting that the answer has to be correct, you can calculate maybe a percent error. Okay, percent error equals answer minus correct answer over the correct answer. Okay, times 100. And so let's just make sure we use absolute value. So we'll take the absolute value of percent error. So now you can say if percent error is less than 0.1%, maybe if you are expecting 3 sig figs, then percent error less than 0.1 would be something that's acceptable. So maybe less than 0.5%, maybe. Okay. You might accept the answer. Then let's see what it does. Okay. Next time, let's submit. 0.0589, 0.059. It still accepts that as a correct answer. Okay. And that's it for this one. So. Alright, now let's reload this spreadsheet because there's something I'd like you to see. If I were to exit, don't save. Okay, I'm going to reload that spreadsheet again. Okay, now look at these numbers carefully. It's 76, 1.36, right? Okay. Now, when I first generate a new question, it gives me 62 and 1.294. Keep that in mind, 62, 1.294. Let's write that over here. 62, 1.294. Let's see what happens if I generate a new question again. This one is going to be 47.4, 1.206, just so we remember it. Generate new question, 76.5, and 1.011. Okay? So, let's save that. And then let's reload it again. And let's see what happens. Okay. Now, what happens if I generate a new question? You'll notice it comes up 62 again in 1.294. Generate a new question, 47.4, 1.206. Generate a question, 76.5, 1.011. So It's not truly a random number generator because it comes up the same way each time. Okay, so the numbers are not really random. What you can do to minimize this problem is, let's go back to our macro. If you want to avoid that, let's click the edit the generate queue procedure right here. Okay, what you can do is you can what's known as seed the random generator. So what you do is you can type the word randomize and then seed it by a number. Put a number on it. And you want that number to be different each time the program is run, that procedure is run, so that the sequence of random numbers would come out different. So when you seed it with the same number each time, the sequence of random numbers that will come out will be the same. So we're going to seed it with a number that changes all the time, and that would be the value of the timer. Okay, so every time it goes through this procedure, it randomizes it and changes the seed for the randomizer. And so in that case, the sequence of random numbers that comes up will not be the same anymore. Okay, so let me go ahead and save that and reload this program. Okay, and now let's run this program again. You can see when I generate my new question, it's 56.3 this time. It's not 62 anymore. So let's go ahead and type that in. 56.3, 1.250. Generate a new question. It's now 64.0 and 1.305. Generate a new question. It's now going to be 79.1 and 0.994. Okay, let's go ahead and save that. Let's see if we get the same sequence next time. So we're going to close and run the Excel sheet again and wait for it. Okay, so generate a new question. Now I don't get 56.3 anymore. I get 36.2. Generate a new question, 54.4. Now it really looks random. Okay. So now it's your turn. Write a similar program for an end of chapter exercise from your textbook or one of the online homework questions that you have in Moodle. Okay. So that will be your homework.